Okay, so we've proven these two identities, okay, sum to product identities using these two formulas. And for the third one, I'm not gonna write the result first. I'm gonna prove it first. So okay, but and with the help of we're gonna do what identity? So we can do it using this cosine A, cosine B, because we have used these two. So the third might be this cosine A, cosine B, and this is equal to half cosine A plus B plus cosine A minus B. If you don't know how this is equal to this, then if you do cosine A plus B, find cosine A minus B, and if we add them up and then figure out what cosine A cosine B is equal to, then you're gonna see that this is equal to this this identity, this thing. Okay, and we're gonna let now this to be C and this to be D. So suppose that those are C and D's, then this will be 2 cosine A, and A will be C plus D over 2, because we have done this kind of calculation right now. Yeah, and B will be C minus D over 2, and this is equal to cosine C plus cosine D, because this is going to be C and this is going to be D. Turns out that cosine C plus cosine D is going to be equal to 2 cosine C plus D over 2 times cosine C minus D over 2, and this is the result that we want. Okay, yeah, so this is the result that we were looking for. The 2 cosine C plus D over 2 times cosine C minus D over 2 is cosine C plus cosine D. Alright, so I spent some time to recognize it. Okay, now for the fourth one we're going to use sine A sine B. Okay, so but let's note down the result. Let's use this. So let's note down the result. Okay, so what's the result? So the result of cosine C plus cosine D was 2 cosine C plus D over 2 times cosine C minus D over 2. Okay, let's talk about the fourth identity. To prove the fourth identity, what are you going to use? We're going to use, let's prove it. So you're going to use what sine A sine B is equal to. So what sine A sine B is? This is half times, okay, what is that equal to? It's equal to sine, okay, not sine, it should be cosine. Cosine A minus B minus cosine A plus B. I hope I've written the correct identity. If I haven't written the correct identity, okay, it will become obvious right now. So this is going to be 2 sine A will be replaced with C plus D over 2, and sine B will be replaced with C minus D over 2, and this is going to be cos is equal to cosine D, okay, minus cosine C. And if you find for what cosine C minus cosine D is, then cosine C minus cosine D will be, you have to distribute minus sign on both the sides. So it will be 2 minus 2 sine. Okay, so let's write the result. Minus 2 sine C plus D over 2 times sine C minus D over 2. This is cosine C minus cosine D. Okay, so I've written the correct identity. Okay, I have written here the correct identity. So what do we have here? Let's write this down. Okay, all right. So what do you have here? We have what cosine C minus cosine D is equal to. And what cosine C minus cosine D is equal to? This is equal to 2 sine C plus D over 2 times sine C minus D over 2. Wait a minute. It should be minus sign here. Okay, miss this minus sign. You can write it in another way as well. What is that another way? So you could do that this is equal to 2, and you can take the minus sign over here, so this will be minus sign, and then minus sine theta, this is equal to same thing as sine of minus theta. So this property we can use for this then. So it will become 2 sine c plus d over 2 times sine d minus c over 2. Maybe like whatever you use it here, then it will be here. You can do it in this way as well. 2 sine d minus c over 2. Okay. Wait a minute. If you distribute minus into this, then it shouldn't be d minus c. It should be minus c minus d. Minus c minus d over 2 times sine c minus d over 2. So these are different ways of writing the same thing. Okay? Alright. So I hope this is clear. So there are different ways of writing the same thing. But this are used most often. You're not going to see that this has been used. This is 2 sine minus c minus d over 2, and then c minus d, sine c minus d over 2. Okay, so these are the identities that we need to memorize. So I want you to memorize these identities. Why I want you to memorize? Because the product to some identities, they can be easily derived. But for this one to derive, you have to derive product to some identity, and then you have to derive sum to product identities. So there are 2 derivation parts. This is why I want you to memorize this. Okay, this is why I don't want you to derive in the exam hall. But for this you can derive. You can derive this easily. Product to sum is derivable, but for sum to product it's not that derivable easily because there are 2 steps. Okay, so why take risk? So that's why you have to memorize this as well. Memorize this. If you have this memorized, then deriving this becomes easy. Then you have a choice. Okay, so you can do it in whatever way you want. But still, I don't recommend memorizing this. Because why? Because you can prove it easily. And for this, memorize. Okay, so what's the way to memorize? Okay, so I have a trick that can help you as well to memorize this. So sine c plus sine d, this is going to be 2 sine c plus d. So sine, if you have sine added up to sine, then sine is a good guy. It has its own turn and also cosine's turn. So yeah, so it writes sine c plus d over 2, then also gives cosine's turn, c minus d over 2. Okay, this is kind of mantra, okay, trick to memorize this. And for sine c minus sine d, if you have minus sign, then it becomes even more, better guy than it was previously. And what it does is, it gives cosine's turn first, and then sine's turns next. So cosine c plus d over 2, and sine. So if we put a minus sign, they become even extra more positive. Okay. By positive, I mean positive in quality. For cosine c plus cosine t, for cosine d, you can think of this as that cosine is greedy. When cosine is added, it produces only cosines as the result, because cosine is greedy. It only has its own turn. It doesn't have sine in it. When you have cosine c minus cosine d, then it becomes even extraordinarily good. Okay, from being bad, now it becomes extraordinarily good. Okay, so this is what happens. For this, it becomes extraordinarily good and gives here sine first and also sine the second time. But one thing that you have to be careful, that the side effect of this being extraordinarily good is that it produces d minus c onto for the second sign. Okay, for the second sign, this trig ratio. So this is the way I memorized it. Okay, and I hope this might help you as well. If it doesn't help you, then find any other way that suits you.